Okay, so you should see this review in Canvas. If you downloaded it prior to today, you maybe see the same thing just without the highlights. Just the highlighted ones are the ones that I'll be doing in class with you guys, but that doesn't mean that's the only thing that you should be studying, right? Try to study everything on the review. All right, but just for the sake of time, I'm going to do select problems. All right, are we all here? Question? So it's going to be a mix of everything that we've done this year so far, right? So starting with exponents, radicals, polynomials, and factoring. So we start with something like this, right? Sometimes they might be as simple as this, but all you have to do for something like this, I see a square on the outside of my parentheses, I can distribute that to each factor. So this is going to become 3 squared a squared, and then there's nothing on the outside of this parentheses, so that's still going to be 6a to the third. Nothing more we can do to that. All right, and then we just want to simplify anything that we can simplify. So 3 squared is going to get you 9a squared times 6a to the third. And then from here, you're just doing coefficient times your coefficient. So 54. All right, this was our very first lesson. Multiplying with the same base, what do we do to those exponents? Add them, so 2 plus 3, 5. All right, nothing more we can do to that. That's your final answer. Question? Sign up. Okay. All right, we can do the same thing with B. All right, what can we do first in B? What's going to make this a little bit simpler?
Simplify 36 and 9.
Okay, good, right? 36 and 9 share a factor of 9. So that becomes a 4 on top and a 1 on the bottom. So I get a 4x to the 5th over 1x to the 10th. And then what can I do with those x's? Yeah, so when you're dividing, good, you can subtract the exponents. So I get 4x to the 5 minus 10. Some questions that I got before, how do you know it's going to be on top? You don't know that the final answer is going to be on top, but when you initially subtract, you should leave it on top. And if you're left with a negative, that's when you can move it to the bottom. All right, so that 5 minus 10 over that x is going to stay on the top and not the bottom. But when we simplify it, we get a 4x to the negative 5 over 1. Now what can we do to that? Good, right? And then this can go to the bottom with that 1. All right, so that's what I mean. Initially, it's going to be on top. But then if at the end you need to move it to the bottom, you should move it to the bottom to make it a positive. And then we get this as our final answer. Yeah, good point. So you don't have to write that 1. If 1 is your leading coefficient, you can do without it. So you can say 4 over x to the 5th. That's also fine. If you write the 1, it's not wrong. I don't really care about that. That's fine. All right, good with those 2 examples? All right, I'm going to move on to the next page. All right, some more examples with simplifying exponents. All right, 35b, there's nothing special about that one. Let me zoom in so you guys get a picture. All right, nothing special about that one. I don't have any sort of exponents over the top of those parentheses. So very simply, I'm just going to multiply these 2 expressions. There's nothing to multiply with that 3. So I'm going to leave that 3 alone. I have a squared and a. You don't see an exponent, assume it's a 1. And again, multiplying with the same base, you add your exponents, so it's going to be 3a to the third. B to the 4th times b to the negative 2 is going to get you a b to the positive 2, right? 4 plus negative 2 is 2. All right, simple as that. That's all you have to do to that one. All right, good with that one? All right, example B of number 36. I see a lot of things here. All right, try to do one thing at a time. All right, in this case, you can do a couple things in one step. And that would be to simplify all of your negative exponents. Right, so any negative exponents you could do in one step. So that 3 to the negative 4, I can change its position and make it a positive. Same thing with 9 to the negative 2. This m to the negative 1, this n to the negative 3, and this n to the negative 3 on the bottom. Right, so many things here are going to change position, so just be careful, make sure that you're moving the correct things. That's where I saw some common mistakes on some more complicated examples on your quiz. Maybe some people got lost with all the work that they had written down and got confused as to what switch positions. So just be careful here. The only thing that's on top right now, that 9 to the positive 2 moved to the top, and that n to the power of 3 moved to the top as well. And then everything else is on the bottom. I have a 3 to the 4th, m to the 1st. I have that m that was already there, and then I have an n to the positive 3. All right, now I can do a couple more things to make it a little bit simpler. Any ideas what we can do first? One of the things that we could do? Okay, good. So you can cancel out your n's. That's what last class said also. Cancel out your n's. Another thing that you could do, you can combine your m's. Right, so this m to the 1st times another m to the 1st is going to get you m to the 2nd. So I get 9 squared over 3 to the 4th times m squared. And then now I can simplify those numbers. On that top, 9 times 9 is going to get me 81. On the bottom, 3 times itself 4 times is going to get you a 9 times a 9, so another 81. All right, and then the last thing we can do, simplify that 81 on the top and on the bottom. These both become 1. So then I get 1 over m squared as your final answer. All right. Someone asked in the last class, and this is a common mistake that I see. I saw it a lot last year in regular. But when some people cancel out these 81s, they say that their answer is just m squared. Right? Maybe in your head when you're canceling things out, you think they just disappear and there's no more fraction. If it was on the bottom to begin with, it should stay on the bottom. So that is going to stay on the bottom. And then when you cancel out common factors, they don't disappear, they become 1, right? The only factor left over is 1. All right, so common mistake that I see. Try not to make it. All right, okay with this problem, guys? Okay. Now I'm going to try 37b. Same thing here. You can try to simplify those negative exponents first. But look at what we have here. We have powers raised to another power. All right, that was also one of our very first lessons. What do we do when there's a power to a power? Multiply, good. Multiply those. And then that 4 to the negative 2, that's not a power to a power, so I'm just going to move that on top. So this is going to be, on top I have a 4 squared. I originally had that 4 to begin with. And then negative 1 times negative 3 is going to get me a positive 3. Negative 1 times negative 1 is going to get me a positive 1. All right. And then we can simplify this. 4 squared is 16. Times 4 is going to get you 64. And then x to the 3rd divided by x to the 1st is going to get you x to the 3 minus 1, so x squared. There's nothing left on the bottom, so you're not going to write that over 1. It was only when you had stuff on the bottom that you would write it, that you would write the 1, right? But you don't have to write that over 1 on the bottom, right? I can just say that this is 64x squared.
Is it wrong if we write the 1 at the bottom?
I mean, no, it's not wrong. You shouldn't though, right? This cleans it up a little bit better. It's not technically wrong. All right, okay with those guys? Okay. Is there anything left on this page? No. All right. Whoa, sorry. So now we have some radicals. Something like this, I don't think I did one like this in class, but there were some on your homework like it. Now, when you're dividing underneath a radical, so the cube root of 64 over 125, I can write this as the cube root of 64 over the cube root of 125. All right, just like with multiplying. With multiplying, you can split it up. Same thing with dividing. And then so we very simply just want to simplify the top and the bottom here. The cube root of 64 is just 4. The cube root of 125 is just 5. All right, okay with that one? All right, and then the cube root of 216 raised to the third power. Couple ways that you could go about this. There's an easier way and then there's a little bit of a longer way. All right, so what we could do is we could simplify the cube root of 216. That does get you 6. So I get 6 and then I still have that 3 on the outside. And then 6 times 6 times 6 is going to get you 216. So it's a little bit of a longer way. Another thing that you could do is recognize that the index and your exponent are exactly the same. They're going to cancel out. And then you're just left with 216. All right, so that's when you have numbers. When you have variables sometimes, and we'll get there at some point later on in chapter 1. We'll get there, but when there's a variable underneath, you want to check those answers. But when it's just a number, you can just cancel it out. So something like the 5th root of 32 to the 5th power. You could say that the 5th root of 32 is 2, and then do 2 times itself 5 times, or you could just cancel out those 5s. Mm-hmm.
Could you quickly explain how you do B?
B? Okay, same idea here. So I tried to steer away from writing it this way. I think when I first taught that lesson, I explained that. But I tried to steer away from writing it this way just because this way is going to be 32 times 32 times 32 times 32, and you're going to make the number super ginormous, and then you're going to have to shrink it down again. All right, but it's the same thing as if I had the 4th root of 32 to the 4th power like that. These are exactly the same thing. All right, and then same idea as before in part A. Same exact index, same exact exponent, just cancel them out, you just get 32. All right, cancel it out, you get 32, no matter how you write it. All right, we okay with those? Excellent, good. Mm-hmm.
So it's gonna be either 32 square root, or is this the answer, or is this?
That one, just the 32, yeah. All right, is there anything left on this page? No. Sorry for how it looks. I know there's a lot of random white space, but we get them like from a textbook, so just wanted to cut out anything that we didn't go over. All right, so let me move on to something like this. A lot of you guys got this one, and then some of you didn't on the quiz, but there were certain things that I was looking out for. Right, so for something like this one, not considered simplified just because there is a radical in the denominator. Bless you. How do we simplify an irrational denominator when it looks like this?
You multiply both sides by the radical.
By conjugate, yeah, good, right? So you flip the sign in between. So if I see a 2 minus radical 3, I'm going to multiply by a 2 plus radical 3 on the top and on the bottom. So this is one of the biggest things that I was looking for. If I saw just this and nothing else, you still got some points because you knew that you had to multiply the top and the bottom by the conjugate. And little differences, even something like this, if I saw 2 plus the square root of 3 and then 2 minus the square root of 3 on top, right, still wrong, right? You needs to be the exact same thing on the top and on the bottom. Question?
Why did you, I thought you put a subtraction.
Yeah, just to show you that it was wrong, right? But just to steer you away from that, right? So plus on the top and on the bottom. Okay. And then on top, you can just multiply as normal. Distribute that 1. That's going to leave it unchanged. So it's going to be 2 plus the square root of 3. And then on the bottom, you could FOIL it. I think I showed you guys a shortcut, right? 2 squared minus the square root of 3 squared. The shortcut's nice. It saves you a little bit of work. Just be careful because I saw some of you on the quiz wrote plus instead of minus, right? This should be minus. And we actually did this not too long ago in polynomials. This is a special product and a difference of squares when we factor it. All right, so has its uses, but remember that it's a minus, not a plus. All right, and then on the bottom, 2 squared is 4, square root of 3 squared is 3. 4 minus 3 is going to get you 1. Anything divided by 1 is itself, so you don't need to write the bottom. This just becomes 2 plus the square root of 3. Plus. All right, so we get something like that.
What do we do right here since it's the power?
Okay, so yeah, the square root and the square are going to cancel out. Right, just like before with that 5th root of 32 to the 5th, right? 5 and the 5 cancel. Whoa, what did I do? Right, if I have the square root of 16 squared, square root and the square cancel out. It's just 16. All right, every single time. Sign out. All right, go with this one, guys. All right, so let's scroll. Let's do a couple like these. All right. So 57. Rational exponents showed up on your quiz, are going to show up on your test. How do we simplify something like this? Very good, right? So the denominator becomes the index of our radical. If it's a square root, do I need to write that there's a 2 there? No, right? I can just leave it. Square root of 16. And then the 3 on top is the exponent. So then I'm just doing the square root of 16 squared. Cubed. Right? And the square root of 16 is just 4. And 4 to the 3rd power, 4 times 4 times 4, 64. All right, simple as that. For something like 58, what do I have to do first before changing it to a radical? What do I see there that I need to take care of? The negative, right? Good, guys, the negative exponent. I'm going to go over this one, and then I'll go over something that was on your quiz that I saw a lot of mistakes on. Right? So something like this, I can draw the line over 1 and then move it to the bottom. And then we end up with 1 over 64 to the 2/3. All right, and then same as before, that denominator becomes the index of my radical. So I get 1 over the cube root of 64 squared. And then the cube root of 64 is just 4, and then 4 squared is 16. So I get 1 over 16. All right, and you guys can write this down too, but something that I saw on your quiz. Now, I think on your quiz, there was a question like this. All right, it took me forever to grade just because there were so many different little mistakes that I saw. But the little mistakes are actually really big mistakes, right? They're things that if you continue to do them down the line, you'll mess up some certain problems really bad, right? So I want you guys to get out of the habit of doing these things. So a lot of you did this part right. A lot of you saw that there was a negative exponent and decided to move it to the bottom. But some of you, that was the only thing that you did. So maybe you did this. Now this is how it should look with those parentheses, but maybe some of you dropped the parentheses when moving it from the top to the bottom. And then you take that denominator of 3 and you put it just over the 64. Do you see why that's not correct? So we get 1 over negative the cube root of 64 to the 2nd power like that. Some of you as your answer for this got 1 over what is that, negative 4 squared, and 1 over negative 16. All right, do we see why that's not correct? Or do I need to explain that a little bit? All right, so when moving it from the top to the bottom, the parentheses don't go away. So this is how it should look. 1 over negative 64 to the 2/3, like that. And then that cube root should be over the entire thing. Should be over the entire thing. If there were parentheses, then you can't assume that it's not. It's just going to disappear from that radical. It's going to be the cube root of negative 64 to the second power. And so I get 1 over negative 4 to the second power, and that is positive 16. All right, I took off a decent amount of points for mixing up that versus that. All right, now you might look and say, okay, it's just a negative. Well, it's not that big of a problem, and like steps-wise. And so if you mess up something like that, down the line, it's going to mess up a lot of problems. Question? Yes, I know. All right, are we okay with this, guys? Okay. So let's do some more. This is where we start our polynomials. All right, adding, subtracting, multiplying, and then factoring. All right, so something like 65 and 66, we're just adding and subtracting. We're just doing our operations. I see a minus on the outside of this polynomial. What that's going to do is that's going to distribute to each of our terms on the inside. Now you could write it this way. I know that in class I like to change that to a plus and then change the sign of everything. No matter how you choose to do it, should still get you the right answer. All right, so if you turn that to a plus, it just goes away, and then we get a negative 3x squared minus 2x. And then now we combine like terms, right? The plus on the outside of this polynomial doesn't do anything to it. It doesn't do anything to our signs. So I'm just going to combine negative 3x squared. There's a negative 2x with a negative 5x. That's going to get me a negative 7x. And there's nothing that I can combine with that 1, so it's just going to be a plus 1 at the end. All right, are we okay with that, guys? All right, 66. I see a lot of parentheses, brackets. What should we do first in this problem to make it a little simpler? Okay, I'm going to simplify what's in the brackets first. All right, we remember our order of operations. Parentheses, that's our first thing to do. Parentheses are any sort of grouping, right? If I have a bracket over this whole thing, I'm going to want to simplify that first. And it looks like to simplify it, I have a negative on the outside. That's just going to go to each of my terms on the inside. So this is going to become 2y squared minus 3y plus 8. Plus 8. All right, and then I still have that 8y minus on the outside. And then from here, it looks like I can distribute that negative to every term on the inside of my brackets. And then that's just going to eliminate the brackets altogether, and then you can combine like terms. So I get 8y minus 2y squared plus 3y minus 8. And then like before, we want to combine like terms. All right, so negative 2y squared, 8y and 3y combine, so I get plus 11y. Nothing combines with 8, so I get a minus 8. And that's my final answer. All right, one thing I do want to specify, maybe you wrote it like 11y minus 2y squared minus 8. All right, I just want to make a note. That's not wrong. I haven't looked at your test, but if the directions say to write in standard form, do we know what that means? I think I talked about it briefly last week. All right, how would I Okay, so we see that this is in standard form. So standard form is an order of decreasing exponent. So whatever variable has the highest exponent should go first. In this case, the 2y squared. All right, so 2y squared is going to go first. The constant, so whatever doesn't have the variable, is always going to go last. And then the exponents just decrease from there. If I don't see an exponent over the y, you assume it's a 1. All right, so this is in standard form. Again, this is technically not wrong, but if the directions say to write in standard form, it's an order of decreasing exponent. All right, are we okay with that, guys? Okay. Okay, now we move on to some multiplying. All right, multiplying, not too bad. How would I multiply something that looks like this? All right, fairly simple problem. Distribute, right? If I just have one single term on the outside, I can distribute it to each of those terms. And as always, it's coefficient times coefficient, variable times variable, right? So 2x times x squared is going to get me 2x to the third. 2x times negative 5x is going to get me a negative 10x squared. 2x times 6 is going to get me a 12x. Nothing more we can do to that. That is our final answer. All right, these last 3 problems are foiling problems. All right, do I need to go over how to foil? No, we're good. I feel like maybe someone shy, so I'm going to do one of them. I'm going to do 69. All right. Foiling a binomial times a binomial is first, outer, inner, last. All right, so I'm going to do my first times my first. As always, coefficient with the coefficient, variable with the variable, so it's going to be 15x squared. 3x times 1 is going to get me a 3x. Negative 6x and 5x is going to get me a negative 30x, and a negative 6 and 1 is going to get me a negative 6. Combine like terms if there are any. I believe in number 70 there's not going to be any like terms. But when there are, you combine them. So then we get 15x squared minus 27x minus 6. All right, and that is our answer in standard form. The next 2 are similar, just different cases, different numbers, different types of variables. All right, are we okay with this page? All right. So I'll do these 2. Now, something like 73. Major mistakes have been made on problems like this. What can we not do here in number 73? Distribute the square, right? Do we see that? We see that we cannot distribute that square. Absolutely not. Nope, nope, nope. All right, we cannot distribute that square. What we can do instead is we can remember either the special product. If you remember, a minus b squared is the same as a squared minus 2ab plus b squared. So you can either remember the special product or you can write it twice and FOIL it. Right? I notice that's what a lot of people tend to do. Right? 2x minus 3 times 2x minus 3. And then you can FOIL it, and that's going to get you a 4x squared minus 6x minus 6x plus 9. And we get a 4x squared minus 12x plus 9. All right, if you chose to do the special product, if you chose to do it this way, might have saved you a little bit of time, especially for something like 74. I'll let you guys do that one on your own, just for the sake of time. But knowing a special product can make some of these problems a lot simpler. All right, and I'll show you with 73, you can very simply square the first, square the last, and then double their product in the middle. Minus 2 times 2x times 3. You still get the same thing. You still get 4x squared minus 12x plus 9. All right, so you get the same thing. Same thing with 74. You can check the notes for that special product. or you can write it 3 times and multiply it. But I will say doing it that way is going to take a lot of time. All right, and these two, 75 and 76, I'm going to set these one up, again, for the sake of time. But multiplying these two, you're very simply just going to write them like any other polynomial product. All right, so something like that. And then like before, you can distribute each of those terms to that polynomial and then write it out. Again, for the sake of time, I won't do this one. All right, for 76, subtracting this polynomial from this one, I talked about something like this last week. If you're taking this away from this, that means you're starting with 6x to the fourth minus 20x squared minus x plus 3. All right. Oh, not times, sorry, minus. Minus, and then you're subtracting this polynomial from it. All right, we see the difference between that and if we wrote it in the reverse order. All right, so it should be written like this. I'm taking this polynomial away from this one. All right, I'll do a couple more with you guys. If you guys don't leave with anything else in terms of factoring, right, you should leave with some steps. The first thing that I would do in any sort of factoring problem is see if there's a GCF. So is there a GCF? That should always, always, always be the first thing that you do. Just because, and in the last class, someone, especially for 84, saw that it was a difference of squares, but didn't see the GCF on the outside. You can factor it either way, but you do need to factor completely. And again, on the test, we're not going to say factor the difference of squares, factor the GCF, factor the perfect square trinomial. We're just going to say factor. All right, and you should know by looking at it which way to do, or which way to factor it. After a GCF, you should check for special cases. Are there special cases? And that was our difference of squares, right? Our perfect square trinomials. And our sum and difference of cubes. All right, so this is what we should be checking every single time. Again, very first thing is the GCF, and then check for your special cases. And you're going to see after this test, there's going to be a step 3 and a step 4. But for you guys, just for the sake of this test, it's only going to be one of these two, or both. All right, so let's look at 81. What's the first thing that we check for? GCF. Is there one here?
Yes.
What is it?
X.
Okay, I can take out an x. And then you're left with an x squared minus 1. Now check for other things, right? Is x squared minus 1 anything special?
Perfect square.
Okay, good. Difference of perfect squares. I can square root the first, square root the second. Our formula for a difference of squares was the square root of both of them. One gets a plus, one gets a minus. And then don't forget about that x on the outside. All right, 84. Again, what's the first thing we check? A GCF. Is there one here? Between 36 and 81? 9. Good. I can take out a 9. So I can take out a 9, and then I'm left with a 4x squared minus 9. Now, is that anything special? Another difference of squares, right? Square root the first, square root the second. One gets a plus, one gets a minus. And then don't forget about the 9 on the outside. Bless you. Now, this is what I mean, because you could square root the first and square root the second from the jump, and then you get 6x minus 9, 6x plus 9. But do we see that there's a common factor in each of these that we still need to factor out? We see that in each of these, 6x minus 9, 6x plus 9, we need to take out the 3. All right, so to avoid that confusion during the test, check for the GCF first. Again, if it's there somehow as you're doing the problem, then that's probably an indication that you didn't take it out from the beginning. There was probably something there that you missed. All right, one more before you guys go. 86. Is there anything special about this? Well, first, is there a GCF? All right, there's no GCF. So then you move on to step 2. Is this a special case? Is there anything special about this?
Perfect cube.
Cubes, right? You guys agree? Cubes. This is a sum of perfect cubes. Do you remember our formula for a sum or a difference of perfect cubes?
A plus B times A squared plus AB plus B squared.
Okay, good. Minus somewhere in there, but good that you remember that. So for the signs, right, some people get confused with the signs. I taught you guys SOAP. Same, opposite, always plus. So same, that plus is the same, minus is the opposite, and then your last one's always plus. And it's going to be the cube root of the first, cube root of the last, and it's going to get you 2x plus 3. And then in our trinomial, right, so that was our binomial. Our trinomial is going to be the square of the first, so 4x squared, square of the last, so 9, product of the 2 in the middle. So 2 times 3 is 6, 6x. All right, the cubes are actually fairly easy if you remember the formula, right? So it shouldn't be too bad. Just make sure you recognize it when you see it. Once again, factoring. Check for the GCF, and then check for special cases. And make sure you're factoring completely. My lesson videos are up. This video will be up today as well.